Hello, everybody. Welcome, and thank you for joining us today for our workshop of Newton's Laws of Motion. I'll be introducing your presenters in just a moment. I'd like to share a few housekeeping items before we get started. I want to let everybody know that in the chat, there will be a link to a shared Google Drive folder. If you didn't have a chance to download the handouts for today's workshop, they can be found in this Google Drive folder. We can also send those after the workshop as well. We ask that you use the Q&A feature on the control panel to ask your questions, and we'll do our very best to answer those questions throughout the session. If we happen to not get your question during the workshop today, we'll definitely follow up with you afterwards. Just to let you know, this workshop is being recorded, and the recording will be on our website after today. We'll also be sending a certificate of attendance to those of you who are joining us live today. And with that, I'd like to introduce you to our hosts, David Carter and Josh Entz.
Hello, I'm David Carter, and I've been using Vernier Probeware for over 30 years now. I got my start when I ran the instructional physics labs at the University of Mississippi a long time ago. And so I did that, taught middle school at one point, done a lot of professional development programs for math and science teachers. And so I've seen a lot of changes over the year with Vernier. So that's who I am. And Josh, I'll let you introduce yourself.
Hi, I'm Josh Entz. I have worked for Vernier now for about 6 years. Prior to working for Vernier, I was a high school physics and engineering instructor in Northern Virginia. I taught everything from conceptual physics up to AP physics. I was a mentor for our school's robotics team. It was a great experience. Since coming to Vernier, I do a number of things, including things like teacher training today. I also do a lot of customer service type stuff. So if you ever have questions about our software or equipment or probes, and you call and you ask for like a physics person, there's a good chance that you'll talk to me. I love helping teachers. Teachers are wonderful customers. We love serving teachers because they do wonderful jobs. They're great people. And we understand that at this time, especially when I'm sure many of you are teaching remotely right now, we appreciate the efforts you're making, and we're doing our best to help and support you as much as we can.
Thank you there, Josh. I see quite a few of you have taken the poll, and it looks like we have kind of a mixture between high school and college. I will say that a bunch of you are saying that you're doing 100% online. It's either hybrid. In fact, only one person said they're actually doing it in person. So we will be kind of addressing how to be able to do some of this online. Just a quick reminder here is that if you would put your questions in the question and answer part of that instead of the chat feature, it's kind of hard for us to monitor both of them. And so questions and whatnot can go there. And so anyway, let's get rolling. So what we want to do today, we're talking about Newton's laws. And so we're going to be showing you some things that are appropriate for teaching Newton's laws. I'm going to start off with just a quick blurb from the website to show you where we're getting some of the things that we're going to be using today, where the downloads came from that Angie put in there for the chat. So you can download that. So I want to share with you first just the website there. So let me go here and share with you. So I'm now at just the home page there. And you'll notice that right up at the very top, it says Explore Remote Solutions. And so there are several things that we've done here to make resources available for you in a remote environment. So I'm going to go here and let's open that up. And I'll just hit the high school tab. There's commonality across these. And so I'll go there to the high school tab. And you'll see some of the things that are there. We did a webinar back in the spring about these resources, but they've evolved a little bit since then. One of the things we're going to be talking about, the Vernier Graphical Analysis, and now we're going to be using the Vernier Graphical Analysis Pro that just came out the other day. And we'll talk a little bit more about that when we're using that. Some of you may have downloaded Graphical Analysis, which is free. Graphical Analysis Pro is a new version that has a cost associated with that, but you can get that free trial for 30 days there. And then Josh is going to be doing some work with the Vernier video analysis, which is a great tool for having students analyze motion. Maybe they put it on their phone or an iPad or a computer or Chromebook or whatever, and they can get videos and create videos and analyze motion via video, which is a good way to be able to do it remotely, because that way they have a tool, they probably have that tool, and can use it there. And so that's he'll be doing that. I'll be starting off showing you some data from the data at home, our files where we have put up labs with the actual documents for the lab, and we put up sample data files for those labs, so that if you're not in a situation where you can have the students collect data, there is data available that you can download and be able to analyze. And that's where that came from. And so if I go here to the library and just say browse library, so let me open that link. And what you'll see there is a list of the various books that are there. And since this is a physics workshop, we won't look at the biology. You feel free to go back and look at that. But what you see there is a list of the different books that we have and some of the labs from those books. We didn't do every lab. Some labs we didn't think were appropriate, didn't really lend themselves to having the data downloaded just because they were too interactive. But that's what's going on here. So it lists the book, it lists the software that's used. And I'm going to be, we're going to be using the Newton's Second Law Lab from the Physics with Vernier book. So this is just our regular physics book here. So some of you may have that one. And so that's where this one came from. I'm going to do a third law lab as a demo. We didn't put it in as one of the downloads, but because this is a Newton's Law, we wanted to do that and kind of show you how that works. And then so here you can download that, you can get graphical analysis and get the app. If you download the entire folder here, not just the individual labs, you actually get the teacher notes for each section too. And you can pick and choose, but it's possible just to click on those and be able to get those. And so that's where the labs that I'll be showing you, that's where they came from here. So. Okay, so at this point, let me stop sharing that screen. And what I want to do is we're going to start in with the Newton's Second Law. Now, there are different versions of this lab. And the version I'm going to be using, grab my bar back here, I'm going to be using the new sensor cart. There's a version that uses a force sensor on there on a card that you would attach to it. This is the force and accelerometer. So you could do it that way. The sensor cart's really nice because it has the ability to measure the force, and you can measure the position, velocity, and acceleration. In this case, we want acceleration. We're doing Newton's Second Law. And it works by using this wheel on the bottom. And so it can measure where it is along the track here. So that's what I will be using for this experiment. So there. In the olden days, you could do it this way, which would be you would attach to the car, you would attach an accelerometer and a force sensor. The obvious drawback there is the wires that are attached. When I ran the instructional labs at the university, we always had to be very careful. You had to kind of walk the cords along with you so that you didn't impart a force. So the sensor cart makes it really easy to do there. So at this point, what I want to do is start up the graphical analysis and show you how the data were collected with this, and then we'll do some of the analysis. So let me go here. And so I'm going to open up graphical analysis. And so what you see there is what it looks like when graphical analysis is just getting started. And because I want to do some data collection with this, I need to turn it on. So I'm going to turn it on. And these new sensors are Bluetooth. Now they can be run via USB, but this is definitely one I don't want to have tethered to a wire. So I want to have it via Bluetooth. And so I've turned it on. And what I need to do is to connect to it via the software. And so I'm going to go here to sensor data collection, and you'll see a list of various sensors that are available for me to connect to. Now, I show cart G, which is this one, it's green. The other is a CO2 sensor that I happen to have over there charging, and it's on, so it's showing up. And so whatever sensors there might show up, but I just need to connect to this cart. And so I'm going to connect there. Now, since we're doing Newton's second law, we're interested in acceleration and we're interested in force. So the force sensor is this part right here. And by default, when you connect to it to the graphical analysis, it doesn't automatically activate that particular sensor. Maybe you're just going to roll the car down the ramp, so it doesn't really know that you want to do that just by default. So to do this, what I need to do is go up here to where it says sensor channels. And I will go there, and you see the options there. And what I want to do is I'm going to check the box next to force, and that will turn on the force sensor. So now I actually have the force sensor activated. Now you'll also notice that it says X, Y, and Z acceleration. Now that's built-in accelerometers for this. We don't recommend for this experiment that you would use those because what's going to happen is the position using the encoder wheel measures position, velocity, and acceleration. You get better data for this particular experiment doing it that way. Now, if I wanted to do something like this and just have it bouncing up and down on a spring, I might want those accelerometers on. But for this case, we just want to be able to measure the acceleration with that. And so let me do this. And so what you see now, we've got force at the top. We have position and we have velocity there. And I'm going to do this. I want to only show 2 graphs, not 3. And so I'm going to go up here to the upper right where it says view options. And I will have it do 2 graphs. And the graph that I want force and I want acceleration. So let me come down here, and instead of it being position, so I want acceleration. Oh, let me turn off position. I gotta remember to do that. So now I have force at the top and I have acceleration at the bottom. Now, if you'll notice down at the lower part down here, we've got these meters in the lower right corner. And what I want to do is I'm going to put this back on the track here. And when it's in that position, I'm going to zero that. So I want to make sure that I zero the force sensor, and maybe I go ahead and zero the position also. And so at this point, we're connected, we're ready to collect the data. And what I'm going to do is just grab the force sensor and actually move the car back and forth. And that's what I'm going to do. What I want to do though is I want to change cameras here. So let me stop that video and then see if I can switch. I may have to stop sharing for a second. Didn't mean to stop the video. I'm sure. So let me switch the camera. So what I've done is there's a camera up here that is aimed down at the track, and so that you can see what I'm doing here. So I will be applying the force like this, and so I'll be moving it back and forth. Now I know since we're broadcasting this via Zoom, there could be a lag in where the data, what the data looks like, and what the sensor, what the video looks like. Just keep that in mind. And so I want to go back and share my graphical analysis again. And so you should be able to see that one. And I will hit the, I'm just going to start moving it back and forth and hit the space bar. And so I'm now collecting data. Maybe not. There we go. Ah. I'm going to try another run. I just knocked that one off. So let me hit collect data there. Here we go. And so the top graph is the force. So, and I can enlarge that. And so we get that. And we have the acceleration there. And there may be something on the track there because I'm getting a little bumpy data. But that's how the data were collected. And so we do that one. And then the other, there are a couple of trials in the data set. And one of the trials, I think the car is actually empty. The other one, you can add these masses. And so the masses end up going here. So you can change the mass of the cart. So if we come back and say I hit collect again, so I've got this other trial, and in fact at this point maybe I want to look at data set 2. So that's the first there, and so those are the 2 different runs there, the good runs with the force and acceleration. So that's how the data were collected. Now, what I want to do is I want to actually open the data file for the lab that we put up there. So let me do this. I want to come up here and I'll just say new experiment and I'll say don't save. And so I need to open the file associated with this experiment. And to do this, one, I want to go ahead and turn this off. I'm going to press the little button here, so I'm just turning it off because when I open it back up, it will reconnect to it, and I don't necessarily want it to do that. And so let me come here and choose file. Let's say we don't want to save that one. And I want to open up Newton's second law. And there's the data that you can download yourself and be able to run the analysis. Now, the analysis part, it has the students go through and it says, well, you've obviously changed the mass, and for it tells you what the 2 different runs are in terms of the cart masses, and so you can choose which run you want to analyze. And the lab says, well, let's look at the graph of force versus acceleration. And so at this point, what I want to do is have one graph. So let me go up here to upper right corner there, and I'll say, well, I just want the one graph. And it's defaulting to saying, well, it's force versus time. But what I want to do is force versus acceleration. So let me go here. And so I will do this. And we get this kind of plot that looks like this. Now, in the experiment, it says for the students to go in, and instead of having it connect the dots, we want to come here, and I'm going to go to graph options, and I want to turn that to points. And so that way it's just the scatter plot of the data we have there. And then, we've got force versus acceleration. What does the slope of that line yield? And so if you want to, we could do that one. And so I can apply a curve fit, and the lab tells the students to do that. And then, so if we apply that, then the slope of that should be the mass of the system. So F equals ma. And so that is how the lab is done. And, it's kind of interesting because kind of the traditional way to do this is, put my hand back over here, would be you might do some kind of like modified Atwood machine where you put a pulley and a weight. And so you only apply a force, maybe a constant force as the weight falls. But here I was moving it back and forth, and it turns out force and acceleration are proportional to each other. So it doesn't matter whether or not the force is in one direction or the other. We're just measuring that. And so that's how that lab was done there. Josh, do we have any questions so far?
Not at this time, Dave.
Okay. So what I want to do now is I want to jump over to the third law lab. And so we will do this. So let me stop sharing that. Let me go back. I'm going to switch my camera. And so I'm going to say new experiment. And we'll just do a sensor data collection. And let me show you what I'm going to do here. Let's see, that one should be off, but yes, it is. I'll tell you what, let's see. So what I'm going to do is take the two force sensors that we have here. So these are the force and accelerometers, and I'm going to hook them together and pull them against each other. So this is the Newton's third law that's in the experiment here. And what it has you do is this. And so basically you're pulling the sensors against each other and being able to do that. And so that's what this lab has you do there. And I guess instead of actually collecting the data live with this, I want to show you a file that I've actually already collected with it. And I used a tool that's new to Graphical Analysis Pro, which is the ability to insert video and have it sync to the data set. And so I want to open that up and be able to show you that. So let me go here and let me open up the third law experiment that I have here. And so what you're seeing there is the data that I collected by pulling them against each other. And what happens is when you set this up, when you're doing anything that's a vector quantity with sensors, one of the options for a vector quantity is to set a direction on the sensor. So you can make a pull positive or a pull negative. And so that's the way this was set up, and it tells them how to do that in the experiment there. And so we have the data here, and so I took the video. All I did was use my phone and collected the video as I collected the data. So let me just show you right now. I'm just going to play back. I can move this over there, and I'm just going to replay the video. And then, so that's what I did. Now, if we go here, this little is enable replay, which not only replays video, it also replays data. And that's a new feature for the Graphical Analysis Pro. And so if I go here, what will happen is if I hit the replay, it will have both the data and the video synced. And that's a nice new feature there. Some of you may recognize that that was something that you could do in our Logger Pro software, and it's one of those features that we wanted to put in there, and so we've just done that. Now, let me kind of show you a little bit of how that's done, because what happens is since the video and the data are actually collected separately. So, I had the video going, and then I'm collecting the data, trying to do it simultaneously, but I can't press both buttons together. And so what happens is that if I go here and examine, so there's a feature there, if I examine, I can move along the data, and you see what's happening on the video. And what I had to do was to come up here and identify what point on the graph matches a point of known time on the video itself. So I know when I first pulled, that would be, where that is. And so it turns out that at 1.6 seconds, the video was actually at 4.32 seconds. And so what I had to do was find out the time for somewhere I knew about, and then come in and actually find the associated time on the video there. And so that's how it's done. So you're linking the two things together, and then of course this allows you to play that back. Yeah, do it again. So imagine, since most of you said, hey, we've gone remote. This is something that you could do where you're collecting some data with sensors, and I could, I'm using the Go Direct sensors, but I could be using something, like a a LabQuest 2 or a LabQuest plugged into the computer and actually collecting the data that way along with the video and be able to sync them together. So there are multiple ways to do that. But you could have a scenario where you have a video of the experiment you want them to analyze, and so they can be able to look at that. And so that's a really powerful tool. Now, there are some other cool tools that are coming along with GA Pro. One thing that's coming will be the ability to data share with the app, which means that you could collect data remotely and have the data appear on the students' screens if you're connected to them. And so that's one of the things that's coming to be able to do that. And so hopefully that will be available fairly soon, because that way you could actually, have an interaction with them. If you're doing a remote, they could be seeing the data as you do something. So it's like almost like an online demo. I mean, of course, here you could save the file and then send it to them, and then they could be able to open it up and do that. So questions, Josh, I think.
There's one in the Q&A right now asking about data sharing, the data sharing feature that you mentioned that will be added to Graphical Analysis Pro. How do we expect students to connect to the data?
That's a good question. It's not out yet. So what would happen is that they're going to have access to the app also. And so we will be able to communicate that. I don't know, because this is a web-based app. So, and so it is, since it's web-based, then, it's connected to the internet to make it work here. And so they would have to be on the internet to make it work. It turns out graphical analysis will run as a standalone if you have opened the app and you don't eliminate the cookies, then you can actually have it run as a standalone. So it doesn't have to be on the internet to work, but if you're going to be doing the data sharing function, you would have to be on the internet to be able to data share that. And since it's not out yet, I don't quite know how that's going to work, but I'm hoping to be able to test that out fairly soon. Okay, well, let me do this. I want to stop sharing, and I think I want to hand the ball over to Josh, who wants to show you some other things.
So Dave showed you a couple of labs there, activities that you could share with students that you might share at the beginning of a Newton's Law of Motion a unit. You're talking about how to explain motion, how to explain changes in velocity and that sort of thing. You might talk about Newton's second law and Newton's third law. Likely down the road in that unit, you would talk about various forces, friction or the normal force, that sort of thing. I'd like to show you another lab that you might share that's about air resistance, another one of these forces that we often discuss. That particular lab is called Air Resistance, and it's also available. You can also download the instructions and the sample data from the sample data library that Dave showed you earlier. A copy of the data and the lab are also in the folder that Angie posted to the chat. So you can find it there. I'm going to share my screen here, and I'll show you the documents in there that relate to this particular activity. So it's called Air Resistance. It's the lab number 13 from our book, Physics with Vernier. When you open the data file, it looks something like this, which can be a little bit confusing. You don't really know exactly what the context here is or how this position data is collected. In the lab itself, you can see there's the description of how this data was collected. I'm going to scroll down here to the procedure, and you'll see that this data was collected from a motion detector. It was attached to the high up near the ceiling, and then pointed down towards the ground, and we placed a coffee filter beneath that motion detector and then dropped it. Now that bit of context, that experimental setup is important to understanding this data, because you can see that if you were just to look at the data, you might think that, well, wait a minute, why is the position increasing? That makes it seem like it should be going up into the air. when we've got a coffee filter that's falling down. You have to kind of understand that to see that, oh, I see, it's actually pointed downward. So when I look at my data set here, it looks like it began about 25 centimeters away from the motion detector, and then moved so that it ended up about a meter away from the motion detector. That's actually this at the beginning here, that's high in the air, and then as it fell, it moved farther away from the motion detector, and so that's why that distance is increasing. In the lab, students look at this position versus time data, and for each of the various trials, they determine the speed at which it fell, that terminal velocity that it fell at. You can see the various trials by clicking on the vertical axis label here. You can see that there are actually 5 data sets here. Well, the first one, the one that's showing by default when you open it, is for one filter, just a single coffee filter being dropped from beneath the motion detector. 2 filters, 3 filters, 4 filters, 5 filters. That last one was a stack of filters kind of nested together. And the graph for each of them all kind of looks the same. They all are dropped about 25 centimeters away from the motion detector and fell till they were about almost a meter away from the motion detector. I'm going to go back to just a single view again. Students are instructed as they read through the lab to figure out that terminal velocity, and you can kind of see that this middle portion of the falling motion here looks pretty linear, like it's falling at a constant rate. And if you click and drag along there and select a portion here that's nice and linear, you can then perform a curve fit on it. I'm going to do here to apply curve fit and choose a linear fit, and it'll give me, the graphical analysis will give me those fitting parameters. And the quantity that students are looking for is this slope here, which looks like it's about 0.85 meters per second. They can repeat that process for each of the trials here. So 2 coffee filters instead of 1 coffee filter. They can go and look and see what the terminal velocity was for a stack of 2 filters. It looks like here it was just over a meter per second. The students then save that, fill out that data table with these velocities, and then they do an interesting thing where they compare 2 different models for the aerodynamic drag. Is the force of the drag proportional to the velocity or proportional to the square of the velocity? They plot that, so they enter the terminal velocities in this column, and then they square them and plot them and enter those values here. And then they open up another window of graphical analysis and plot, the number of filters, or that terminal velocity versus the number of filters, and look at which one of those models better fits the data. It's kind of an interesting way of looking at it, and it is a great way to kind of talk about how we explain forces, how we describe forces. Typically, we, especially in a introductory physics class, you might talk about things like gravity, where it's a force that's constant. And so discussing air resistance is interesting because you have this force that's proportional, that varies with the velocity. Terminal or air resistance is likewise one of those questions that naturally comes up when you talk to students about things like projectile motion. So it's great to be able to do a lab where you can engage with air resistance and kind of discuss why does it work the way it does. So this is kind of like a great way of doing it. Like I said, the students need to be able to, they download this data file, they will read through the instructions, and they really need to have those instructions to be able to relate to this data. As Dave mentioned, Graphical Analysis Pro has the option of allowing you to sync video with a data set. And Dave created his own data set there for Newton's third law. He recorded the video and recorded him pulling on it with the force sensors. Graphical Analysis Pro also has a number of these experiments already kind of built into them. So I'm gonna minimize this a little bit so you can see this graphical analysis a little bit better here. And I'm going to open a new data file here. I'm going to go to new experiment. I don't need to save that dialog because it's data because it's available elsewhere. And I'm going to go here to the sample experiments option. These are the sample data and videos that are kind of built into Graphical Analysis Pro. They're from a whole variety of subjects, tied primarily to the lab books that we've created in the past. I'm going to go here and look at just those labs from our Physics with Vernier textbook or lab book. And I'm going to choose this air resistance lab. This is the one that we were looking at here. And there we go. As it loads, you can see, as Dave showed you before, this data file doesn't just have data in it, but it also has a video. And I can run this video. The first couple seconds kind of just show the experimental setup. And then it shows the actual video file, the video the video that's synced to the data. I'll go to this replay option here, and I can do the same sort of replay. So shows that video, and then as it gets to the data collection portion, you can see the video synced to the data collection. I really love this examine feature, how it's linked to the video. It's wonderful. You know, sometimes things, especially in a physics class, happen so fast that it can be hard to kind of connect that data to the graph that you see, the physical phenomenon. And by linking the video to the data, you can kind of get that sense. As I scroll back and forth here with my examine tool, I can see where the coffee filter was at each of those moments in time, and can I see how a little more clearly how the physical phenomenon is related to the data. So I see there's one question about saving or downloading the data files from from the Google Drive, and how do you open them from Google Drive? The easiest way to do that is depending on how you have Drive linked to your computer, but typically what you want to do from Google Drive, if you right click on the data file and choose download, it will move it from your cloud-based Google Drive to your computer itself, the computer you're using. And then from within graphical analysis, I'm going to go here. From within graphical analysis, if you choose open or new experiment, you can choose this open saved file option here. And at this point, I'm not going to say that. You can go to, like this is pointed to my downloads folder, and I can it'll show me any graphical analysis files that I happen to have in my downloads folder, or you can navigate to elsewhere to find that data file and then open it there. There is that step though, you got to download it first or put it someplace where graphical analysis will be able to find it before you can open it. Are there any other questions I can answer before moving on? So if you think about students kind of doing data or data analysis, lab activities from home, the best thing that they could do would be to collect data themselves and analyze it. It's kind of hard to do that in a remote learning situation. Being able to download, we've provided these data files free up on our website to help give you some sort of like lab experience. They aren't obviously collecting the data themselves, but it's great that they can at least do the analysis portion and think through the analysis of the data and link that to what they are learning, otherwise. The Graphical Analysis Pro, that's available now. It's purchased software, although there is a 30-day free trial that you can sign up for. That adds a little extra layer to it where you can actually see a video synced to that data that helps them kind of connect to that data and understand it a little bit better. That's probably a little bit better of a remote learning experience. Perhaps the best remote learning experience we can offer at Vernier right now is using our Vernier video analysis software. Using this software, you can actually collect data at home, just using a smartphone or any sort of camera, and then import that video into the software and analyze it. And so they could do a complete lab experience from a home. I'm going to show you a similar activity to this, what we've done here, a following coffee filter activity. The video that I'm going to use is one that's already been created and is available as a free download or free sample data or free sample video with Vernier video analysis. But it's the kind of thing where you could have students collecting their own, making their own videos and then analyzing them through the software. So I'm going to switch from graphical analysis here. I'm going to switch over to, this is just within a browser window here. I've got Chrome open. And Vernier video analysis is an app that runs within the browser. So you can see that the kind of the location here is videoanalysis.app. With Vernier video analysis, it all starts with a video. So you can import your own video, if you or your students have created your own, or there are a number of sample videos here. A lot of teachers use Vernier video analysis to analyze projectile motion. That's kind of like the most natural application of the software. But you can do all sorts of investigations, any sort of motion things where things are moving around on the screen. That's where video analysis really comes into play. I'm going to go down here to one of the sample videos, which is this coffee filters, and choose that one instead. And it loads my video, right? It loads the video within the app here. I'm going to just play it at first so you can see what it looks like. It's pretty simple, just like with the other lab that we were doing, the air resistance lab. You've got a stack of coffee filters. The first one is only a single filter, and the other ones are 2, 3, 4, 5 filters, that sort of thing. And it's just a video of those filters falling. This video is taken very carefully, though. You can see that the lighting is really good. They've used a flat black background. You can also see that it's been scaled. Overlaid on top of the video is some information. For instance, the mass of the stacks of coffee filters. You can see these guidelines show kind of like the distance from where it started, that sort of thing. So it really is, this video is great. It's kind of been carefully set up so that you can do a real quantitative lab using the data you collect from here. Now, the way that you collect data within Vernier video analysis is you drop data points kind of on top of the graph. So right now I've got, I'm ready to collect data here. I'm going to move my this guy out of the way so it's a little more front and center. And I can click and collect data on any one of these graphs or any one of these falling coffee filters. I'm going to choose the first one to collect data on. And because this was filmed using high-speed video, when I click, it's going to advance to the next frame, and I can click another data point. Sometimes it's a little hard, especially with high-speed video like this, to track the object or see the change in the position of in this case, coffee filter from one frame to the next. So I'm going to change a setting here, and rather than advancing just one frame, I'm going to advance 10 frames here. And so I'm going to collect some data. So there's a data point left there. And then it's moved a little bit. It's advanced 10 frames. And I'm going to move to the next one. And likewise, if it's a little hard to see, did it really move too much? You can always turn off the data markers, the trails there. So it's a little easier to see. And you can track this coffee filter through the whole course of its fall here. And now as I click those data points, I'm also getting a graph and a data table. You might wonder, like, well, where's that data coming from? Well, I've got a time column. I've got a horizontal position that's given the variable x, a vertical position that's given the variable y, and then an x velocity and a y velocity. Now, time is measured in seconds. That kind of makes sense. I would measure time in seconds. And the video analysis software is getting that time from the timestamp in the video. It knows the rate at which the video is recorded at, and so it's applying a timestamp for each of those data points accordingly. The position of those data points, I'll turn these back on, it's getting simply by counting pixels. It's using the lower left-hand corner here as 0, 0, and then saying, okay, how many pixels to the right and how many pixels up? I can convert that from pixels to an actual distance because I have a scale here in my video. So I can go and if I choose the system here, I can kind of move this stretchy line around. The video is using the distance in pixels of this line and converting that to meters. So I'm going to move this over here, and I'm going to take and say this right here is 1 meter or 100 centimeters. And this little conversion here tells me that it's just about 700 pixels is equal to 1 meter. And by doing that, I can see that my data table now has been converted from measurements in pixels to measurements in meters. Likewise, I can choose an origin, and I can kind of move that around here. If I want, I can say, I'm going to set the 100 centimeter or 1 meter mark here as my 0 in the vertical direction. And as I do that, likewise, it scales, it moves these, my data table, the values in my data tables to match the origin that I've now chosen. Rather than go through the whole process of clicking on all those positions there, I'm going to cheat. I did this earlier today, and I'm just going to open a new experiment here that has that data already included. I'm going to open my saved data file here, and I want this terminal velocity lab here. And you can see I've completed the data collection over here. That's what all these little dots are. On the right-hand side here, I've got, therefore, like a complete data table. I'm going to move that a little bit out of the way so we can see the graph a little bit better. We have a free lab that comes with, you can just download from our website, that it's written for this particular software, the Vernier video analysis. It's called Terminal Velocity, and it's very similar to the air resistance lab that I showed you a moment ago. In this lab, it's a little bit better. It's a little more geared towards calculus-based physics course, so AP Physics or like college-level physics. And it looks at this velocity curve. How does that velocity change over time as it approaches terminal velocity? And so students collect data from their video and then plot velocity versus time and then perform a curve fit. Kind of guides them through the process of choosing this natural exponent mathematical expression for the velocity. The data fits really well, as you might imagine, and the lab talks them through understanding these particular quantities, these fitting parameters, A, B, and C. So that's a very similar experience to what students would do if they were just downloading the sample data or you're providing that sample data from our library. But it adds the actual, data collection portion to the lab experience, which is really valuable. So sometimes knowing where that data came from, actually collecting the data yourself, really makes it much easier to kind of understand and interpret that data as they get to that second part. For Vernier, video analysis is like Graphical Analysis Pro is a paid software. You have to buy it. But just like Graphical Analysis Pro, we do offer a 30-day free trial. During that trial period, you can use Vernier video analysis with your students. So you'd share a link with them, and they could open the software within their browser as well and perform this lab. I put the terminal velocity lab in the Google Drive that Angie posted for today's workshop, so you can download it and look at it there. Likewise, in that Google Drive folder that Angie shared in the chat window, there is a document that has links to kind of all these things: where to get graphical analysis, just the free version; where to find Graphical Analysis Pro, Vernier video analysis; how to sign up for the free trials for those pieces of software if you're interested in that sort of thing. So I'd encourage you to look there and to find, look at those links, and if you're interested, sign up for those free trials. Dave, do we have any questions at this point?
Well, here's a question. How many students, let's say you buy this license, how many students can use it?
Okay, yeah.
That number or what?
So Vernier Video Analysis is sold as a site license to schools, a site license subscription for schools. So like I said, there's a free 30-day trial. If you want to purchase it for a school year, it's $149. And that covers you, your entire school through June 31st of next year. So you can share it with your fellow physics teachers at your school and use it with all the students that you've got. So if you've got 600 physics students at your school, they're all available. They can all use it. They'll all use the same link, and that'll be good through for the whole rest of the school year.
What about this question? What kind of device does it need to? What does it have to run on? Does it run on Chromebooks?
Yeah. So Vernier Video Analysis runs within a browser. It runs within all the modern browsers. So I'm using Chrome here today, but it'll run in Edge and Firefox and Safari. And so you just need a device that will run a modern browser. So that could be a Chromebook, it could be a computer, a PC, a Mac. It'll also run on iPads and Android tablets. So long as you can get a modern browser like that, it just runs within it. So you don't have to install it or anything like that. In fact, it's a little funny because you gotta remember that because it just runs in the browser, the way you want to find it later is you gotta bookmark it like you would any other website. Fortunately though, because it is like an app and it's not just a web page, you can bookmark it and then disconnect from the internet, and you can always just open it up from within your browser. You don't have to be connected to the internet. Once you've linked to it once, you don't have to be connected to the internet to use the video analysis app again.
So at this point, let's see here. We'd like to kind of throw it open for other questions. We're getting close to the end here. We didn't know if you had some other questions, either for graphical analysis or video analysis. We'd be happy to answer that. Go back here and turn that back on. Josh, can you show us how you would actually distribute the app if you,
Sure.
When you get that license?
Let me go here. So there's a lot going on in the video analysis screen right here. The videos obviously show up in the on the left-hand side. You get a data table and a graph on the right-hand side here. Just like Graphical Analysis Pro, you can kind of resize those. If you want, you can get rid of like the data table. Likewise, just as the same as in Graphical Analysis Pro, you can also kind of replay your the data collection and analysis that you've got going on. It's kind of cool. My curve fit is adjusting as we go here. And you can kind of see again how your data is linked to the graph and that sort of thing. There are a number of options here to kind of make your life easier when working with videos. You can kind of trim a video from within the app, by moving these sliders here. You can edit data points, once they've been collected. You can actually track more than one object at a time. So if you wanted to be able to have track all, have a separate, you wanted one data file with the track of all 5 of those following Caulfield filters, you could add them. This also has worked really well for if you want to analyze collision videos, so you've got 2 things colliding with each other, a set of billiard balls or colliding carts or something like that, and you wanted to look at that conservation of momentum and that sort of thing. You can track more than one object at a time and look at the transfer of momentum from one to the other. Likewise, Vernier video analysis has a center of mass function. So if you want to look at in a collision like that, how does the center of mass of the system move, you know, as during the collision, before, during, and after the collision, you can. And you can always, of course, save the data files to your device, you know, whether that's your computer or iPad or whatever, and share that with an instructor or a lab partner, that sort of thing. It's saved as a VMBL file, which is a file format that's specific to Vernier video analysis. It includes the video, the data, any data you collected, as well as analysis and that sort of thing. And then to get to Dave's actual question here, in the upper right-hand corner, there are a number of things that are available that are kind of like, that might be helpful. There's a user manual. This is just a PDF that explains the data collection and analysis process within Vernier video analysis. And there's an option here to distribute app. This really just gives you the opportunity to copy a link, and then you can paste that link into, or you guys, first you could email it to students, or if you've got a class website, you could post it up on the class website. Students would then click on that link and it would open the app within their browser, you know.
So at this point, any other questions, comments? I know we're just about out of time, but we've got just a few minutes here. Now, since I'm not seeing any questions there, but I know that one of the things I didn't really speak to when I did my session about the Graphical Analysis Pro or Graphical Analysis is that it too, you know, it runs in a browser. And so basically, if you have a modern browser, that's what's required to make it work. And so it's, you know, it does work on Chromebooks, you know, iOS, Android devices, you know, Mac, PC. So any of those devices will work. So yeah, that's nice to be able to do that. So I did not mention that.
So there are a couple of questions here in the Q&A. The first is, where can I find a recording? I assume that's a recording of this particular workshop. We will take a day or so to kind of edit this video, the recording of this Zoom meeting here, and then post it up to our training page. So you'll be able to find it there. There are a couple of, there are already, so this is to answer Robin's question, there are already a couple of workshops that we've done that are up on the web page there. So just look for, if you go to www.vernier.com, or maybe I'll just share my screen so you can see that.
Josh, it'll be in our video session.
Yeah, so there's a video section within the trainings here that you can get to. I don't want to come out of my way here. And you can find those guys there. So educator training, and then videos. And then you can kind of see, these are some of the workshops that we've done recently. And this one will be posted up there so that you'll be able to find it with the others as well. There was one other question about Pivot Interactives. We have partnered with Pivot Interactives to bring that kind of platform to our customers. It is a wonderful tool. It's a little bit different than Vernier video analysis. With Vernier video analysis, you're really analyzing just kind of motion and that sort of thing. Pivot offers a whole variety of lab experiences, more than just analyzing the motion. They have tools built into them, into each of the videos, that allow you to collect data from those videos. It really is, it's a whole platform. It's not just videos. It's not just a tool like Vernier video analysis that you would use with like a lab that you've written. Rather, it's a whole platform that has activities written around the videos that they've created. And then, you know, the students respond to questions and multiple choice questions, and they perform calculations all within the platform itself. It's got obviously therefore a grade book and that sort of thing. So it's very similar. If you're interested in Pivot Interactives, there is we did a very similar webinar to this one earlier this year about pivot. You can find also on this on these video page on the video trainings. If you go to the pivot page on the Vernier website, there is also, you can find more information there about how it works. And there's a video kind of on that page as well. Like I said, it is a wonderful platform, especially for remote learning situations that many of you are in today. And it's just a great way to have that real lab experience remotely.
Well, I think we are out of time there. So Josh, you want to put it back so that we're both there. So we'd like to, we appreciate you guys giving up some time to come here. We'll be doing more of these, and we've tried to time them such that they kind of fit into where a lot of people may be in terms of the curriculum. And so, you know, obviously you're here for physics, but, you know, we've been doing biology ones and chemistry ones, and all of those we're trying to do in kind of in a timely fashion. So we'll be having, I know we'll be doing a circular motion. We've got some other ones coming up in the near future where we'll continue down this path there. So thanks for coming. And if you have other questions, we can answer some of those offline. You know, download those free trials and give it a shot yourself. So again, thanks for coming.
Keep in touch.